This is the second part of CHUMP, which uses an EEPROM to program the code onto CHUMP after each subsequent clock pulse on the program counter, and the output is represented by these 8 LEDs, representing the output of the code. It is currently displaying Dave Feinberg's code. So if I use this switch right here, I will pause the program, and if I click this button, which is the clock pulse, in monostable mode, it will advance the code onto the next line. Here is the first line of Feinberg's code, which is 0x82, then 0x10, 0x21, 0x62, and finally 0xA0. And then the remaining lines are all 0xFF. I also have two dual 7-segment displays here, but unfortunately these EEPROMs don't work, so I can't use the 7-segment display. In order to program this EEPROM, this burner circuit is used, which consists of 2 shift registers, and of course the EEPROM that is programmed using this nano. And here's how the code works. First we define our pins right here, and then we call our first function, which is set address, which basically sets the address in EEPROM, and we go with MSB first, bit shift the address 8 bits to the right, and we have this ternary operator which will disable the program if the output enabled pin is high, and then we set latch to high and then low so that the program is updated. And we have our read EEPROM function, which will basically read the state of each IO line on the EEPROM from pin D0 to pin D7. It sets it as an input, and then we read the digital state of each pin by bit shifting the data one to the left. And finally, we have our write EEPROM function, which has 2 parameters, the address and the byte, and we call the address function, and we set each IO line as an output, and then we write to it by bit shifting the data one by one to the right. We have the function print contents, which will print the contents of the EEPROM. It will read each byte of data, and then it will create an array which will print out each element in our data array right here. So we call our byte data, and this is where I have Feinberg's program. And there is also a hex decoder line, which you can use to connect our EEPROM to a 7-segment display. Finally, we call standard shift register procedure. Then we erase the contents of the EEPROM, and we do that by writing to it and configuring it to the address of 0xFF, which is the default value of the EEPROM. And then we program it by calling the write EEPROM function again and putting the values in our data array that we have defined above into the EEPROM. And then finally, we read the contents of the EEPROM. Thanks for watching.